Okay, so today we're doing what we call molecular geometry. Okay, syllabus outcome for this is investigate the role of electronegativity in determining the ionic or covalent nature of bonds between atoms. Investigate the difference between ionic and covalent compounds through using nomenclature, valency, and chemical formulae. Blah blah blah. Basically, we've covered most of this before, but this is the key thing at the end here: modeling the shapes of molecular substances. Okay, so have a go at the revision questions at the top of page 103. We're going to go through the answers now. Lewis structures are a way to show the structural formula for simple compounds. Um, Lewis structures show valence electrons as dots and covalent bonds as lines. And after creating a Lewis structure, you need to ensure that the number of electrons around an atom follows the octet rule, except for those exceptions. Those exceptions being sulfur and phosphorus, which can do 10, boron, which can do 2, hydrogen, helium, boron can do 6, and hydrogen and helium can only do 2. Okay, so always remember those exceptions. So molecular geometry. So why is it that when we show a picture of water, the water is always bent? Okay, well, the answer is valence shell electron pair repulsion theory, or VSEPR, whatever you want to call it, VSEPR theory. So this valence shell electron pair repulsion theory is based on the fact that electron pairs being negatively charged feel repulsion away from each other. Okay, so just like positives and negative charges like to come together, negatives and negatives push away, positives and positives push away. So, so like with magnets, opposites attract, likes repel. Um, the bonds or the spare electrons, we also call them lone pairs of electrons. You might have heard me mention that in the last lesson. They arrange themselves around an atom to be as far away from each other as possible. Now, if we have two things around an atom, they like to be linear, so they like to be as far away from each other as possible. If we have four things, we get what we call a tetrahedral shape. So we basically have three coming down, one going up, and they're all equal distances from each other. Now, those four things, they could either be four different atoms, they could be three atoms and a lone pair of electrons, or two atoms and two lone pairs of electrons. We can also just get three things around an atom, which gives us what we call a trigonal planar geometry. Okay, so it's basically the points of that will effectively produce an equilateral triangle. Okay. Now some examples. CO2 is a nice linear one. H2O is bent. Boron trifluoride is our trigonal planar example. Remember, boron can have 6 electrons in its outer shell, so it's pretty happy doing that. The tetrahedral things are something like methane or tetrachloromethane, something like that. And trigonal pyramidal is NH3, so we have 3 bonds to the hydrogen and a lone pair of electrons left over. So to be able to accurately predict the shape of a molecule, you first need to draw the Lewis structure. So if you're not 100% on Lewis structures, you'll have to go back and practice them first. But for everybody else that is okay with it, we can continue on. And this tells you if there are any lone pairs of electrons. So it tells you how many bonds there are and how many lone pairs of electrons are. So it dictates the shape of the molecule. So one example. So what is the molecular geometry of water? So that this is it here. Basically, first step is to draw the Lewis structure. The molecule is in the form of AX2, so it can either be linear or bent. But because we've got two pairs of electrons in the valence shell, the molecule becomes bent. Okay, so it's basically tetrahedral with two of the things being electron pairs. So if you have a look at our table, it's AX2. It's got two outside atoms, two lone pairs. It's bent. Okay, so determine the molecular geometry of ammonia. So we take the Lewis structure from ammonia. We did this example last lesson. It's in the form AX3, so it could be either trigonal planar or trigonal pyramidal. But we have to have a look and see if there's any lone pairs of electrons, and there is one. And so because there's one lone pair of electrons, it becomes trigonal pyramidal. So again, looking back at that table, just up above, three outside atoms, one lone pair, so it's trigonal pyramidal. So determine the molecular shape of the following compounds. So CH4, H2S, CO2. So the way we do that, we get our Lewis structures. So this is methane. So we can see it's got 4 outside atoms and 0 lone pairs. So that one's going to be tetrahedral. H2S, so we have S has 6, H has 1. So we're going to form a bond there and a bond there. Each of them has 8 around it, except for hydrogen, which has 2 around it. So that's our Lewis dot structure. We can see that it's got 2 outside atoms, 2 lone pairs. So that's going to be bent. Now CO2. We did this example last lesson, so we know the structure of carbon dioxide should look like this. So 2 double bonds connecting to the central carbon. So if we have a look at the table, 2 outside atoms, 0 lone pairs, that one's going to be linear. Now, as a bit of an extension, just to show you guys what um, you know, all the different types of shapes out there, I'm going to show you a table that actually has a fair few different ones. Now, this probably won't be needed for the course. The main ones are the ones that I just showed you. But there's all these different types here. So we can have up to 6 bonds around certain atoms, especially things like sulfur, metal ions in particular have this sort of stuff. But basically, these are all the different shapes. So lots of them can be bent or angular. There's a lot of trigonal stuff. We also have tetrahedral. Um, and when we start to do things with 5, we can start getting weird things like trigonal bipyramidal. We something we call sawhorse or seesaw, which is a bit odd. T-shaped and linear ones. Okay, so there's all sorts of things that we can get there. And so that I just want to show you that just as a bit of posterity, just in case someone asks, what if there's 6 bonds? Well, this is what happens. There's lots of different shapes we can have. Now, summary. So the shapes of simple covalent molecules depends on the arrangement of the electrons around the atom. The valence shell electron pair repulsion theory indicates that electron pairs move as far away from each other as possible. And to draw the molecular structure, you need to first draw the Lewis structure. Okay, so once you got that down, there's questions at the top of page 107, so please have a go at those.